We've been over multiplying matrices, but I wanted to give you a couple of examples, 2 or 3, just to remind you if you get stuck on how to multiply matrices. The first thing that you have to do is you have to determine the two sizes of the matrices to see if you can even multiply them. So in this first example for this first matrix, this is 2 rows by 2 columns, a 2 by 2 matrix. Looking at the second matrices, again I have 2 rows by 2 columns, a 2 by 2 matrix. To see if you can even multiply them, you look at the inner dimensions. If they are the same, then yes, you can multiply the two matrices. They have to be the same. If they're not the same, then you can just stop and say you can't multiply them. The answer matrix will be this row by this column. So this is 2 rows that your answer will be by 2 columns. Sometimes it's easier if you go ahead and you just set that up. So I know my answer is also going to be a 2 by 2, 2 rows by 2 columns matrix. And I get that from here, this 2 rows and the outer dimensions by 2 columns. Then you're going to multiply row by column, row by column. In this first matrix, you're going to look at the rows and you're going to stay in your loops. If you go ahead and draw them, it's probably easier. So I have these 2 rows and these 2 columns. Then you're going to multiply row by column. Multiply somewhat corresponding elements within the rows and columns, and then you're going to add those 2 products. In other words, I'm going to multiply 2 times -3 and get -6. And then I'm going to move down, -1, come down to -5. -1 times -5 is a +5. Add those 2 together, and this answer is going to be -1. Then I'm going to go back to this same row, and then I'm going to change it to this second column. So here I have 2 times 2, and I get 4. Then move down the row and column. -1 times 1 is -1. Combine those, and that answer is 3. So that's the first row, the first and second column. Now you're going to look at this second row right here, and you're going to do the same thing and apply it to both this first column and this second column here. So now I have 3 times -3, you've got to go back to the beginning, 3 times -3 is -9, then 1 times -5 is -5, combine those, and that answer is -14. Staying in this same row, apply it to the second column. 3 times 2 is 6, 1 times 1 is a +1, and then you combine those and your answer is 7. The way, of course, your final answer would look would be a 2 by 2, just -1, 3, -14, and 7. And your answer is going to be that 2 by 2 matrix that we determined it would be. Another example, kind of undo all of this and move things out of the way. Is if I have different dimensions. If my dimensions are somewhat different, I have to determine if I can multiply, and then what my answer will look like. In this first matrix, I have a 3 by 3 matrix. In the second one, I have 3 rows by 2 columns, 3 by 2. Remember, this is always going to be written as row by column, like that RC color that we've been talking about. So I first determine, can I even multiply these? Since these 2 are the same, yes, I can multiply them. My answer will be the outer dimensions of 3 rows by 2 column matrix. So I'm just going to kind of just set this up. I have 3 rows. Let me go back. I have 3 rows by 2 columns. So here's my 3 rows by 2 columns. And that's the way that's the size of that matrix is going to be, 3 rows by 2 columns. Again, I'm going to pick my columns and my rows, and I'm going to circle first of all the rows. That's my first matrix. Let me make that so I can be sure that you can see all your numbers and all your signs. Don't cover up or circle out a sign. That's something to be real careful of. And then here are my 2 columns. Now here you're going to have 3 products within your matrix. So when I have these 3 products, I'm going to start at the beginning. 2 times -3 is -6. -5 times -5 is a +25. And then 0 times 2 is 0. When I add these together, I get 19. Staying in this first row, now go to the second column. 2 times 2, right here, is 4. Negative 5 times 1 is negative 5. I'm just moving down the row and column. 0 times 4 is 0. When I combine those, I get negative 1. Now I go to this second row right here. Start back at the top in the beginning. 1 times negative 3 is negative 3. 0 times negative 5 is 0. Negative 2 times 2 is negative 4. Combine and you get negative 7. 1 times 2 is 2. 0 times 1 is 0. Negative 2 times 4 is negative 8. Combine and you get negative 6. Now I'm on that third row. Even in my answer, I'm on my third row. That kind of tells you where you are. Third row, first column. Start back at the beginning and the top. Positive 3 times negative 3 is negative 9. 1 times negative 5 is negative 5. 1 times 2 is a positive 2. Add those up. Negative 9 plus 5 is negative 14, and the positive 2 is a negative 12. Then I go this row times this column. 3 times 2 is 6. 1 times 1 is 1. 1 times 4 is a positive 4. Add them up, and you get 11. And of course, you're not going to have all that written in your answer. Your answer will just be 19, negative 1, negative 7, negative 6, negative 12, and 11. And your answer again is a 3 by 2 matrix. One more to show you. Moving all this out of the way. So when I'm multiplying these two particular matrices, the first thing I do is determine what size matrix that I have. So in this first one I have 3 rows by 2 columns. So this is 3 rows by 2 columns. Again, we're reminded that this is row by column. This is 3 rows by 3 columns. It turns out to be a square matrix of 3 by 3 rows by columns. I initially look at the inner dimensions. When I look at these two inner dimensions, they're not the same. So you can write, just so you let me know that you can't multiply, NA, not possible. A lot of times the directions will tell you what to write, but I can't even multiply these two matrices, so I go no further. Those are just some examples of multiplying matrices.